All right, so we are in for the sixth derivative rule tonight, and that is the quotient rule. So you can see here that we're doing the derivative of a quotient, so a function in terms of x divided by another function in terms of x. And this saying down here that we see is really important in helping us to memorize. You'll hear us say this over and over, and you'll memorize it. So it's low d high minus high d low all over low squared. And you can see where that comes from. F of x is your high, g of x is your low. And so it's low d high, derivative of the high, minus high times derivative of the low all over low squared. So I want you to make sure that you get that down. Say it several times out loud to yourself. It should roll off your tongue. Low d high minus high d low all over low squared. And understand that d stands for derivative, low is the denominator, and high is the numerator of that quotient. All right, so we're going to go ahead and use this rule now and practice a few examples. Okay, so we're going to look at our first example here, and we're asked to find the derivative of h of x, and clearly we can see that this is a quotient. We have a function in terms of x on the numerator, and we have a function in terms of x in the denominator. So we have to use our quotient rule, okay? So we're going to go ahead and say h prime of x equals. All right, so now we're going to set up our fraction. And remember we said that the saying was low, so low here is x squared plus 4. D high, so that means we're taking the derivative of the numerator. So that would be 3x squared plus 10x. And then the minus 3, of course, the derivative of that is 0, so that's gone. Okay, so that's low d high minus high. So I'm copying the numerator, x cubed plus 5x squared minus 3. D low is 2x. And again, the derivative of 4 is 0. Okay, so we have that all over low squared. So x squared plus 4 squared. All right, this is pretty ugly, and we do need to go ahead and clean it up. Okay, so h prime of x. All right, so in the first here we have a binomial times a binomial, so we're going to go ahead and FOIL that out. So we'll get 3x to the 4th, and then plus 10x cubed. Okay, and then plus 12x squared. And then plus 40x. Okay, this next piece here, we have minus, and then this whole chunk. Okay, so it might be helpful, depending upon your algebra skills and how quick, how fast you can do this. You might want to go ahead and do the distributing of the 2x up on top here, and then negate that all and write it down on the line. Okay, so down below in your answer. So if I distribute this through, I'd get 2x to the 4th plus 10x squared, and then minus 6x. So when I bring that down here, okay, I'm going to have minus 2x to the 4th, then I'm going to have minus 10x squared, and then plus 6x. And all over that x squared plus 4 quantity squared. You usually don't have to expand that out because there's nothing in the numerator that we're going to combine it, or denominator that we're going to combine it with, so you can just leave that as is. So h prime of x equals, all right, so now we should be able to combine some like terms here. So the x to the 4th is the 3 and the negative 2, so that's 1x to the 4th. There's only one term with an x cubed in it, so that comes down, 10x cubed. Then the x squared, 12x squared minus 10x squared is 2x squared. And then 40x plus 6x is 46x. All over x squared plus 4 quantity squared. Okay, so that is the derivative of h of x, and that's your first experience with the quotient rule. There it is. Okay, let's take a look at a second one. So again, as we pause before we just jump into the quotient rule, we want to make sure that the numerator and the denominator are both functions of x, and in fact they are. So we are going to go ahead and use the quotient rule. So y prime equals low d high minus high d low all over low squared. So low here is our sign of x. D high, so the derivative of the high is 2x. Minus high is the whole binomial, x squared plus 3, d low. So if you remember, this derivative of sine is cosine of x, all over sine of x squared. All right, so let's clean it up. So y prime is equal to, all right, when we multiply sine x times 2x here, we're going to put the 2x in front. Remember, you are not multiplying this 2x by this x here. This is an angle. This is going to become a coefficient. So it's 2x sine x. Okay, and then we have another subtraction up here in the numerator. And again, we have a binomial times cosine of x. So again, I'm going to bracket that off, okay? I'm going to distribute the cos x through up here. And so I'm going to get x squared cos x plus 3 cos x. And so now, again, I'm subtracting that whole thing. So as I bring that down, it'll be negative x squared cos x minus 3 cosine x all over. All right, when you square a trig function, you can write it as I did up there. You need the parentheses. Okay, if you don't have the parentheses, it's going to look like the angle is squared, that the x is squared and not the sine. So you want to square the function, so we write it as sine squared x, and that should be familiar to you. Okay, at this point, there's nothing in the numerator that I can clean up, and I cannot divide this sine x here. Some of you are getting confused with this. I can't divide this sine x by this sine x because we have this subtraction here. So unless it's a product, I cannot cancel that sine x into the numerator at all. And since every term does not have a sine x, I can't cancel anything out, and so we're all done. All right. Number 3. All right, taking a look at this next one, we want to again take a look at the numerator and denominator, and we notice that they are in fact both functions of x. But the numerator here, you should notice, is a bit more complicated. It's not just one function of x, we actually have two functions of x. We have 2x cubed, and then we have cosine x. So we actually are going to have to employ two of the rules that we've just recently used. On the top, you're going to have to use that product rule that we used last lesson. And then for the whole thing, we're going to have to use the quotient rule. All right, so just keep that in mind that when I do the derivative of the numerator, I actually have to use the product rule inside of my quotient rule. All right, so let's get going on this. F prime of x equals. Okay, so we're going to do low x squared minus 7. Oops, make that look like a squared. D high. And so I'm going to go ahead and use a different color so that we understand we're doing the derivative of the numerator. And as we said, the numerator is a product, so we have to use the product rule. So I'm going to bracket that off and go ahead and recall the product rule. So we have first times the derivative of the second plus second times derivative of the first. Okay, so our first, this is our first, and this is our second as far as in the product rule. So we have first, which is 2x to the third, times the derivative of the second would be negative sine x, plus second is cosine x, times the derivative of the first would be 6x squared. Okay, so that was all the derivative of the numerator. So go back to our saying for the quotient rule, low d high minus high. So our high here is that 2x cubed. I'm going to go back to the other color. Okay, so minus 2x cubed cos x. Okay, d low. So the derivative of the low here is 2x. All right, all over low squared. So x squared minus 7 squared. All right. So now we got to clean this up. So the calculus part is done, and now it's just a matter of getting in that pesky algebra, okay? So f prime of x is equal to. Okay, so I'm going to keep that x squared minus 7 just as is for a second. I'm going to clean up the blue, the brackets, okay? So when I multiply 2x cubed times negative sine x, I get negative 2x cubed sine x. And then when I multiply cos x times 6x squared, I can put that 6x squared in front, so 6x squared cosine x. Okay, then as far as over here, and we have 2x cubed cos x times 2x. So the 2x cubed and the 2x can be multiplied to make 4x to the 4th, and then cosine x. All over x squared minus 7 squared. Okay, for time's sake, I'm going to go ahead and leave that as is. What I really do have here is a binomial times another binomial, just very long. So if I wanted to clean it up a step further, I could go ahead and FOIL. I trust that you could do that. Okay, but I'm going to leave it as is and move on to the next problem. Okay, looking at this next one, we certainly have had practice with these over the last couple days. Find the equations of the tangent line and normal line to the graphs of the function at the x value. So again, we're asking for equations of lines. We're given a function and we're given the x value. Remember, anytime you're asked for the equation of a line, we need point and we need slope. Okay, so in this case, when we're given the x, we're already given the x coordinate of our point. So x is the pi over 2. What we need to do to find the y, well, y would be f of pi over 2. So that would be sine of pi over 2 all over 3 times pi over 2 minus 5. Okay, so we need to remind ourselves what the sine graph looks like so we can evaluate sine of pi over 2. So remember, our sine graph looks like this, okay? And pi over 2, well, this is 0, here's pi, so pi over 2 is right here, and we can see that the sine of pi over 2 is in fact 1. So sine of pi over 2 just turns into 1 over, this is our y value, 1 over. Okay, 3 times pi over 2 would just be 3 pi over 2 minus 5. All right, we don't like to have a fraction inside of a fraction, so I'm going to go ahead and multiply both the numerator and the denominator by 2, the whole thing here, and that 1. And that will clean it up to make it 2 over, so 3 pi over 2 times 2 is just going to be 3 pi minus 10. All right, so that's our y value. All right, so now we need to worry about our slope. Well, remember, our slope is synonymous with the derivative. So we're going to go ahead and do the derivative of f of x. Well, the derivative, if we look at that function, that is in fact a quotient, where the numerator and the denominator are both in terms of x. So to do the quotient rule, I have f, so let's squiggle that down, f prime of x equals, okay, low is 3x minus 5, d high, the derivative of sine is cosine, minus high sine x, d low would just be times 3. Okay, so all over low squared. Be careful with that low squared. I know a lot of times last year students would just forget the low squared. So don't forget your quotient, you're going to get a quotient. All right, so at this point I'm going to go ahead and plug in my pi over 2. All right, so I actually should have written here, okay, f prime of pi over 2, because what I need to do is evaluate, that's the derivative. Yes, it looks kind of messy, but remember, we're solving for the derivative in order to plug the pi over 2 in to get the value of the slope, okay? So we can go ahead and put that in. It would be 3 pi over 2, 3 times pi over 2 minus 5 times cosine of pi over 2, okay, minus sine of pi over 2 times 3. All over, okay, 3 times pi over 2 minus 5 squared. All right, so we now have to evaluate cosine of pi over 2 as well. So if I look at my cosine graph up here, okay, the cosine graph looks like this. Again, we can tell that this is halfway through, that's our pi. So halfway between 0 and pi is right here, is pi over 2, and that in fact is 0. So this whole thing right here is 0, which means that everything to the left of that minus sign here is going to be gone, okay, because 0 times anything is 0. So good thing we didn't spend time cleaning that up because it's just going away anyways. So f of pi over 2 is equal to 0 minus, All right, now sine of pi over 2, we already figured out over here. Sine of pi over 2 was 1. So 1 times 3 is just 3. All right, over. All right, the denominator, we have a fraction minus a whole number all squared. So we're going to go ahead. We don't want that fraction into the denominator. So we're going to, first of all, 3 pi over 2. I'm going to get a common denominator. So this would be 3 pi over 2 minus, well, if I want a denominator for the 5 would be like 5 over 1, so it'd be 10 over 2. So 3 pi minus 10 all over 2, and that's squared. Okay, so this would be negative 3 over. All right, well, when you have a fraction squared, now there's lots of different ways that you can do this, but this is the way I would do it. Okay, when you have a fraction squared, it's the same as the numerator squared. So 3 pi minus 10 quantity squared all over 2 squared would be 4. All right, now why did I do that? Well, because I could tell that my denominator was a single term, so I could square that out easily. Now, if I have this fraction in the denominator and I want to get rid of it, I multiply the top and bottom by 4. Okay, so what does that do for us? Well, now finally we get f prime of pi over 2 equals, so negative 12 over, when we multiply this fraction in the denominator times its denominator, we're going to go ahead and get just the 3 pi minus 10 squared, which we're going to leave as is. Okay, so there's our slope. And here's our y value. And of course our x value is pi over 2. So we have the 3 things we need. So we're going to go ahead and write our tangent line. Okay, so to write our tangent line, it would be y, so this is our tangent, y minus, okay, our y value is right here. It's this ugly fraction. 2 over 3 pi minus 10, okay, is equal to our slope is this other ugly fraction, negative 12 over 3 pi minus 10 squared times x minus pi over 2. All right, so that's the equation for the our tangent line. Now if we need our normal line, okay, well, our normal line, remember everything is the same. The point is the same, except for the slope is going to be the perpendicular slope, so the negative reciprocal. So we still have y minus 2 over 3 pi minus 10 equals. So negative reciprocal, we're just going to go ahead and flip it and negate it. So we'd get 3 pi minus 10 squared all over positive 12 times x minus pi over 2. So there are our 2 equations of our 2 different lines. All right, so taking a look at this last question, you're asked to find the equation of another tangent line. The tangent line 2f, and notice here's the f of x, okay, at x equals 2, so we're given our x value once again. Given the following table, we need this table because if you look at our function f of x, it's in terms of x, but it's also in terms of g of x and h of x. So this is another one of those, has some symbolic differentiation that we have to do. All right, so first of all, we need to find our point, right, and also our slope. Okay, so to do our point, well, we know our x value is 2. All right, so we need to find our y value. So f of 2 equals, everywhere we see an x, we're putting in a 2. So 3 times 2 squared would be 4 times g of 2 minus 7 times 2 would be 14 over h of 2. All right, so again, now here's where we pull out from our table. So 3 times 4 is just going to be 12 times g of 2. Well, g of 2, okay, looking over here at the table, g of 2 is in fact negative 2. All right, so 12 times negative 2 minus 14 divided by, so now h of 2 would be negative 1. So 14 divided by negative 1. All right, so this is negative 24, and then this would be plus 14, so y would be negative 10. Okay, so our x is 2 and our y is negative 10. All right, now we need to do the slope of this. Okay. Okay, so I kind of slid myself down here. So I summarized that my point was 2, -10, and now I'm ready to do the slope. So I gave myself a little bit more room here. All right, so if we take a look at this original function, all right, we were given f of x is equal to 3x squared times g of x. So you can see here, okay, this here, 3x squared times g of x, well, that looks to me like it's going to be the product rule, minus 7x divided by h of x. Oops, that was supposed to be h of x, okay? That to me looks like the quotient rule. All right, so we're going to go ahead and use the right rule with the right part of each of these problems. Okay, so we have f prime, oops, okay, f prime of x is equal. So first the product rule, so that would be first 3x squared times the derivative of the second. So remember, when we take the derivative of g of x, we just write g prime of x, plus second, which is g of x, times the derivative of the first, which would be 6x. Okay, that's our product rule. Now minus, and now we are doing the quotient rule. So I'm going to kind of bracket that off. Okay, so that would be low h of x, d high, so the derivative of 7x is just 7, minus high, 7x, d low, again, the derivative of h of x is h prime of x, all over low squared. So that's h of x squared. Okay, so we found that derivative, and the derivative, remember, is the slope of the tangent, so that we could put in 2, so f prime of 2, and I brought the table down because we're going to need that as we evaluate this. So we're going to put 2 in for x, so 3 times 2 squared would be 3 times 4, so 12 times g prime of 2 plus g of 2 times 6 times 2 is 12. Okay, minus. All right, so this would be h of 2 times 7 minus 7 times 2 is 14 times h prime of 2 all over h of 2 squared. All right, so let's go ahead and evaluate what each of these are. So 12, using our table, g prime of 2. Okay, so we want to make sure that we go to the g prime function, and this is our x value, so g prime of 2 is 3. All right, so times 3 plus g of 2. Again, look at the table. G of 2 would be -2. So -2 times 12. Okay, minus. All right, h of 2 is -1 times 7 minus 14 times h prime of 2 is 4. All over h of 2 is -1 squared is just 1. Okay, so we have 36, and then this is going to be -24, so 36 minus 24 is going to be 12. Okay, minus -1 times 7 is -7, minus 14 times 4 is 56. So -7 minus 56 is going to be -63. So that's 12 minus a -63. So our slope here is 75. Okay, so in conclusion, our tangent line is going to be y plus 10, using this point here, and this slope here. Okay, so y plus 10 is equal to 75, x minus 2. Okay, there are 2 definite times when we want to avoid the quotient rule. And so we want to be aware of this because, yeah, you can use the quotient rule for both of these cases, but it's a lot more work and it's a lot longer than we need to. So if we can avoid that, doing it the longer way, which is probably going to induce more mistakes, we can go ahead and definitely recognize those situations so we don't use the quotient rule for these 2 scenarios. In the first scenario, we have f of x is equal to 2x plus 5. 2x plus 5 is a function in terms of x, but 10 in fact is not. It's a constant. So the first one is if your numerator or your denominator is a constant, you're going to avoid using the quotient rule. Instead, I would want you to rewrite this as f of x is equal to like 1/10 times 2x squared plus 5. Which again, that's not the product rule, okay, because 1/10 is a constant. So you could then distribute that through and have 2/10 or 1/5 x squared plus 5/10, so plus a half. Okay, and then you can do the quotient, or just the regular old power rule from that. All right, so that's one time when you're going to avoid the quotient rule, and you can see here that now if we have f of x as 1/5 x squared plus a half, that's much easier to do than if we were trying to do low d high plus high d low over low squared for this whole fraction. Okay, the second one, and we did ones like this when I introduced the power rule to you. Here, if in the numerator, again, numerator and denominator this time are functions in terms of x. And so you would think, oh, this would be time for the quotient rule. But if you notice, our denominator is a monomial. So only when the denominator is a monomial. This does not apply if the numerator is a monomial. Stress that in your notes. Write yourself a note. Okay, so if you have a polynomial divided by a monomial, then you're going to go ahead and do what we did, like I said, in our notes last time, okay, when we did the power rule, and you're actually going to split this into each of these, okay? So that would be 1/2 x to the third minus 3/2 x to the 1, or just x, and then minus 5/2 x to the negative 2. And again, now you're just using your power rules to find the derivative of g, which is much quicker than the quotient rule. All right, so that should finish it up for today. Thanks a lot, guys.